And this presentation is a little higher level in terms of, so it's more about using an application, focusing on edge computing and blockchain technology, which is a lot in the news today. So this is just a background on DSApps. We launched about almost 20 years back, and we are focusing a lot on collaborative applications, building process automation solutions for enterprises. And more recently, we've been focusing on the smart city area. So we were selected last year for working with the LA Department of Transportation on some of their next generation transportation 2.0 projects, going all the way to the Olympics. So their plan is to go for going for an autonomous tomorrow. And so I'll actually go through a use case of that. So feel free to stop me anytime and ask me questions. So make it more interactive. Now, in terms of blockchain, how many of you are already working with something to do with blockchain? Okay. So it is certainly a new platform, and it's actually much simpler than what they make it out to be. So the outline of the talk, we'll sort of look at what is profoundly different, about blockchain. Like, why is it? What is so different, and why is it more than just another way to store data? And we'll also look at why blockchain can be a game changer for boosting trust. So the main code is here. The main keyword is trust, and how this can boost trust. It could be a game changer for in-memory databases. Then the performance bottleneck, how blockchain can actually help that. We'll also look at edge computing, focusing on edge computing, which has the highest, one of the best matches for blockchain technology, and how it can, why it benefits from blockchain technology. Focusing on speed, reliability, edge computing, when you don't have cloud support. So the thing here is, cloud support is not always guaranteed, and we'll look at those use cases which where you have to work without the cloud. And what are some of the major public-private blockchain platforms? So you hear a lot about this. So quick sort of a summary of those platforms. The use case I talked about, focusing more on the LA Department of Transportation and the whole autonomous tomorrow. And we are working on a specific curb management application. So I'll sort of look at why this is sort of ideal for blockchain and in-memory. And then we'll look at some other use cases and wrap up. Okay. So this is you must have seen a lot of these on the internet. And there's a lot of predictions on the growth. It's 42% plus annual growth. There's a lot of applications listed out there. So we'll see why this makes it so, what is so different, why these cannot be, what would really make it different from using a relational database, for example. So just as, the big, and you must have seen this many times before, it's all about a shared ledger that is shared among members, and it's distributed. It's immutable, so it cannot be changed, and it's highly trustable. So that's sort of the top line, that this is really a way to share a ledger which is distributed, trustable, immutable, right? So let's see what makes it so. And when you have this sort of a ledger, then you can get all these. You can actually prove ownership. So you have a place for you to, store your coins, for example, for you to manage, cryptocurrency and so on. So Bitcoin, for example, there's a way for you to build and maintain trust among multiple partners. So that's a supply chain, for example. When you have buyers and sellers who are entering into contracts, so there's a way here without middlemen, without having any other channel. So directly buyers and sellers can enter into contracts. And so again, it's trust. The keyword again is trust. And again, when you enter into contracts, so there's ways in which you can automate those contracts. So we look at, again, what makes it so. So for example, here's an example of market trading. So you can actually have trading between buyers and sellers without the need to go through, for example, S&P or a Dow Jones or something. So all you have really is the exchange, and it's been set up through blockchain. So this is the going down to what makes it so trustable. It's all about cryptography. So we can think of your data being partitioned into blocks. Now these blocks can be rows, they can be pages. So you can define your block in any manner. But each block, we compute what is called a SHA-256 hash. So you've got the first block, you find the SHA-256 of that, and you store that hash in the next block. So let me use this pointer here. So I'm sorry, took me back. Let me try this. Yeah, this block here, the hash of this, and the hash is the SHA-256 function. The SHA-256 is chosen because it's an extremely fast cryptographic function, right? So this hash is stored in the next block. So if there is a change, in the content of this block, then the hash will not match anymore, and so this link will be broken. So each of block is connected to the next one through this chain of hashes, and that chain is stored in the next block. So it's really like building a wall. You have this wall up here with, and each block has got the hash of it is stored in the next one, next one, next one, next one, so on. You make any change to any of those, blocks, the entire wall collapses. So it's the beauty of, it's an extremely simple concept, but just storing that hash and storing in the next one and then storing the next one. So for example, if the content of this one changed here, back. The content here changed, then the hash would change, and this will not match the hash in this one. So therefore, we have a number of use cases that you see out there, and so let's look at why these. And these have been running successfully with databases, with Oracle, IBM, Microsoft. All these relational database servers have been. All these applications can work with those databases. So then you wonder what is so new that you need, blockchain for that. So this is the question: what is new and profound that cannot be done with traditional database servers? So this is just one. If you look at a ledger, a traditional database server update versus a ledger update. When you have a ledger, this is an old-fashioned ledger. When you record every transaction, it's like you know exactly what's going on. When you have a server, you're sort of pushing a button. You're communicating to the server a certain action, and you really don't know what happened out there. You're sort of working under. You want to know you don't know if the server is down. Did we really act? Is the data current? Was there any hacking that caused problems? The safe server administrators, if you want to make changes, it is expensive, right? So it's like pushing a button and hoping it all goes well, Whereas in the case of a ledger, it's very simple. You've got the ledger, it's old-fashioned almost, and you make a commitment, you write it down. Now, of course, you'll share it with other members, and the beauty is when you share it, everything that you share in the ledger is immutable. So it's an immutable ledger. So you make a note, it stays forever. So the actions are visible, recorded, and it's transparent and trustable. So this movie, this is Jerry Maguire in the movie. They had this scene where he says, "My word is my bond." So they basically, he's trying to sign him up, his son, and he's says, "Word is my bond." He's going to join you. He's going to use you as an agent, and the whole idea of blockchain technology is you are eliminating the middle person. You don't need a lawyer. You don't need anyone else. It's just between two people, right? So if obviously if this thing didn't work out, you're going to say, show me the money. Basically, the contract didn't go through. So it gives you a way to work with blockchain technology, the ability for end parties to directly record and execute a trusted agreement without the intermediary, without institutions. So when that paper was written, the Nakamoto, that was in 2008, and they wanted to basically, not be in the mercy of the banks, the big banks. So the requirements of blockchain, you certainly need an immutable distributed ledger. You need members, a member network, who sort of have a consensus mechanism, a way by which they can agree, some way by which they can agree. Okay? So different blockchain networks have different techniques. Right? So if it's public versus private, public, like Bitcoin and so on, there's something called proof of work. Private, you can set up your own consensus method. And then there's this thing called smart contracts, which which is basically it's a programming language. You can sort of set the action. What happens if this happens? If then else sort of thing. So you can actually define the actions, and all the transactions are trusted, verifiable transactions. So the whole blockchain adheres to all these security pillars. Availability, auditability, accountability, integrity, confidentiality, and so on. But this entire thing is at the mercy of performance. So performance is a huge problem in the blockchain, this thing. So therefore, we'll come to that actually. We'll talk about why it is. So the major benefit for what it provides you is trust. That's the key word, trust. So you talk of extreme performance, extreme capacity, extreme scalability, and now you have this thing called extreme trust, a new word in information technology or the world of computing. Extreme trust, a new dimension, and that provides you all these new things. You can actually set up contracts. Contracts are sort of the foundation of how humans interact with each other, businesses interact with each other, and it's always been done with middlemen, with escrow agents, with lawyers and so on. And now we can do that actually, but you can enter into contracts without middle institutions. You can prove your ownership of something. You can prove ownership of titles and so on. What we call provenance or tracing the origin, without depending on title companies, without depending on institutions and so on. And collaboration. So you can drive collaboration processes. And this is a big, this actually is one of the most important things when you're working with edge computing. Security, you can flag abnormal transactions, audit, because you have all these transactions in a ledger. And things like knowledge, you can capture best practices. For example, there's something called AI on a chain, this new concept. So people are talking of actually building AI algorithms which have been sort of proven or whatever, and then storing them on a blockchain so that others can benefit from that. So you're sort of sharing best practices. So this is the big thing, the energy requirement. A Bitcoin transaction, for example, takes 5,000 times as much as using a Visa credit card. So it's a massive amount of, there's this thing about a small city's worth of electricity. So they actually shut it down. They had these data centers working to mine Bitcoins and so on, and it found so much of power is being consumed. So this is one of the bottlenecks. And I just took this quote from, just Googled and found this interesting one from Grid Gain, the CTO, about how blockchain, all the requirements in terms of performance, and you can actually get 10 times faster than disk-based solutions with in-memory. So in-memory computing is one of the most effective ways of solving that. And so we look at the So if you look at in-memory computing, which has all these benefits, in terms of boosting computational performance. And if you look at blockchain technology, which requires highly trustable shared data, computing of hashes, being able to distribute the ledger, synchronizing those ledgers. Now those map very well with blockchain technology. So you're getting this performance benefit. You're also getting the distributed support. So in-memory computing can provide a lot of the benefits that can drive blockchain technology. And then the reverse is, blockchain technology can provide the trust to in-memory computing, which actually could be a game changer, because now you can actually store your, billions of records in a database which is in memory, and even if the power goes off and whatever happens, you can be sure that when it comes back, it's completely trusted, because you can prove through the hashes that your data is just as it was before. So this is a sort of almost a game changer for this in-memory computing. And you may not have seen this before in terms of as a new fact, but certainly, blockchain is a game changer here. And blockchain requires a lot of computation. There's things like security certificates, which guarantee that it's very distributed architecture. So it's when you have all these different nodes interacting with each other, you want to make sure that you use those stronger security protocols. So X509 security certificates are used, and computing those requires certainly something like in-memory computing. So this is actually a huge benefit here, and so we will now let's look at edge computing apps. So in terms of edge computing is basically defined as, that's where the sort of the source of the data. So this is your familiar, you've got this, he's got an account in the bank, and he says, I cannot trust the bank, but I can always trust my passbook. So he's got all his data in a passbook. So it's like having a ledger, and you very familiar this thing, an old application, right? And you got the bank. But tomorrow, what happens is, there's a family. There's each of them has passbooks. So these are like ledgers, and they all have to be synchronized. So you need to synchronize ledgers. Also, people go to a job, and you may shop, and it's not necessary for you to go to the bank each time. Perhaps you can open a credit directly with the shop based on your job. So you can now actually set up a blockchain network, and you can directly transact services, directly pay and receive. The bank is no longer a necessary part of the of commerce, almost. So it's almost like saying, and bank to some extent represents cloud computing. You don't necessarily need this big, this big institution. You can still do everything just by transacting within the network. And of course, you will use it for example, for global transactions, large loans, analytics, and so on. So it's optional, but it's just another member. So a lot of the things can be done on the edge with edge computing. So this is just a sort of an example of. And why does it benefit significantly? Because the key is highly trustable local data storage. So if you have an edge computing application, and we'll go through some examples here, you need local data storage. You need local data storage that is shared. It has to be shared among multiple members. And it has to be trustable. So, and it has to be synchronized. So this maps perfectly with blockchain technology. So that's sort of the key for edge computing. So these are use cases for edge computing. These are examples of use cases. So for example, the first one here is on transportation. Tomorrow it's going to get much more. There's so much drive towards autonomous world, smart transportation, and so on. It's actually they're ordering their driverless shuttles right now. So the cities are gearing up. It might take 10 years for the whole thing to happen, but there's a lot of activity going on there, and you cannot, if you're on the road and you have to make very fast decisions, you cannot do that by going to the cloud all the time. 5G may or may not happen, and 5G requires all these transmitters. So even with 5G, it's not a guarantee that you can have the cloud. So you've got to manage your computation on the road, be able to dynamically assign parking and so on, without necessarily access to the cloud. So the speed of the edge is one of the most important criteria. The other one is if you have poor cloud access, and if you're in the middle of the ocean, you got this container ship, and it's in the middle of the ocean, and some of the produce has gone bad, and there's no way to communicate to the to a central server. But yet they have to make decisions on, okay, I have so many millions of dollars of cargo, I need to now change my contracts, I need to maybe go to, instead of going to Argentina, I'll go to Brazil or something, maybe I'll change my contract, maybe I'll do, so you can do all those things, rework your contracts even if you're out in the edge. So again, something you can support global supply chains. Manufacturing is extremely, when you talk to manufacturing managers, they don't want to be dependent on the cloud. All their IoT sensors, it's an absolute, one of the requirements. It should work without necessarily going to the cloud. That it should be able to work with local area networks and so on. So you will certainly need a network of some sort, but not necessarily going all the way to an Amazon server. And then of course tomorrow's this whole sensor network. You have such a large number of inputs coming in that you have to record and so on. So how do you trust that? You need to trust it. You need to be able to record those in places and then be able to process them. So so edge computing actually is extremely critical for IoT and for handling machines, sensors and so on, gateways. So it's really all about if you have if you don't necessarily have central computing, cloud computing all the time. Yeah, any questions here? So if you compare traditional cloud service to edge smart blockchain, you've got this is your typical cloud server. You've got it's like a data center operation. It's highly structured. Whereas edge smart or edge computing applications, flexible, highly the edge can be very fast. There's got to be some way of distributing a shared ledger supporting local copies. Whereas in this case, we have centralized control. We've got all the data in one single place, perhaps for the entire application. Whereas here, you may have local data. For example, it may be within a street level. If you're doing, if you're managing transportation, maybe in a segment of the road. So you've got to have local copies, and it has to be extremely trustable. And there may be changes, so you have to be ready for changes. So it should be suitable for changes. Here, it's not really designed for changes. So we can now add edge computing, part of that, the previous picture. So now this is sort of this is almost, the image that trying to. So if you look at in-memory computing, driving performance, driving distributed support, blockchain technology, it also significantly provides performance advantages here, provides distributed support, and blockchain provides the trust and security. So for all these apps that require speed, reliability, working without the cloud, and requiring edge analytics. So the challenge is how do we integrate blockchain with edge and cloud? And for that, we have to now start looking at all the conditions, all that we need to make happen. And for example, so when you go from edge to cloud, you have to maintain session status. You have to maintain encryption keys, manage encryption keys, execute smart contracts. So for this, we use different there are different blockchain platforms available. There are two types, broad types: uh, the public type of blockchain platforms, and the private ones. So Hyperledger is a private. It's really a private network. Ethereum, Ripple, these are all examples of public. They can also work in private, but the biggest benefit is as a public blockchain, and they use different consensus mechanisms. Here, it's more of a. It's driven by the private network. So if you have a bank or something which has a private network, for example, Mastercard has launched its own network. So they're using Hyperledger. It's a private network, right? Whereas if you're using Ethereum, for example, you may be managing titles, real estate titles, for example, and there it would be managed through Ethereum, and they use different consensus, algorithms. And so we won't go into detail on that, but one of the problems here is always performance. Performance is not good at all with with these public blockchains. Whereas with the private ones, you can add unlimited nodes. So there's a huge benefit here. And typically for all edge computing applications, we'll be using pretty much sort of a Hyperledger type private this thing. And there are other. Hyperledger is it's an open source. So a number of companies have gotten together. There's IBM and others who are behind it, but it's certainly not the only one. So there'll be more to come for this. So we can certainly see new types of private blockchains being set up. It's complex. So this is one of the disadvantages. It is not that user-friendly. I mean, it does take a lot of work to make it happen. Ethereum is much simpler to set up smart contracts, but they do it's not free, so they do have a gas tax. So when you work with Ethereum, they do charge for contracts. Privately controlled, of course, it's. So this is typically for, customer facing, and this is more for B2B businesses. So this is just a short. We'll make these slides available. So it's a summary of Ethereum, Ripple, which is sort of very similar to Ethereum, and Hyperledger. So Hyperledger is backed by these big companies, and it's not necessary for you to use them. You can always set up your own Hyperledger platform without having a large person. You can set up your own network, but the benefit is governance, access to legacy applications, and so on. So these, all these companies are going after the Hyperledger platform. So there's an example of Microsoft Azure. Right? They have gone in for actually an Ethereum type. They use Ethereum as the where they store, and it starts with, for example, devices. Then you have gateway, devices like IoT devices. You have gateways, and then you store these in, like, for example, Azure SQL databases. Right? So you store them in an Azure platform, and then from here it's stored in a ledger, a distributed ledger, which is using the Ethereum platform. They do plan to go for Hyperledger in the future. So this is a future kind of thing. IBM is being standardized on Hyperledger. So they've got it's running on the Watson, the IBM Cloud. So it's a very large initiative for them. Along with pretty much Oracle and SAP and all the others. All of them are very big on Hyperledger. It's got develop platform, and then there's an operation platform. So this is where you actually launch the Hyperledger. The benefit is you get all these services. So it includes a lot of security and crypto services. And this is where you're actually storing the data, the ledger. So it's part of the. So to give you a simple idea of what it looks like, this is an example of a hyperledger fabric. And these P's are all the peer nodes. So you can set up as many peer nodes, P1, P2, P3, right? So you can finally, these are all basically running on Linux. It could be a single board computer, could be a Raspberry Pi, You could have a whole network of these. S is a smart contract, and L is a ledger. So you've got the same ledger copy in every one of those nodes. And S1 is a smart contract which also is running on those nodes. So the security for this is extremely important. It's based on X509 certificates. This guarantees it's more than just username password. You also need the X509. So the certificates are issued through. There's actually a certifying authority, and you can set up a full process of how these certificates are issued for different devices. So it's pretty complex. So again, we will not go through the details here, because I'm going to come back to the use case. So I don't want to take too much time on the low-level technology here. But you can issue certificates, you can register IDs, you can issue certificates, and you can revoke certificates. So certificates are core for a distributed nodal network. So example, when I talked about this transportation model, when you have all those curbs, then each curb is a node. Your car is kind of like a, it's a member of the network. So you need to park somewhere, and that place is taken. You got assigned to that, and as you go to that, the place is taken. So the sensor has to direct you to the next one, automatically. So it's very dynamic, and you want to make sure that all those members are trusted through certificates. So very quickly go through a smart city use case here. So this is called Vision Zero. So I'm going to a little high level now of what, this is going to specific to LA. So they've got a very large initiative, one of the largest, most complex problems they've got. So one is to reduce deaths. So by 2025, it's called Vision Zero, right? And a lot of it, most of the accidents are caused by people, and they've really taken this thing that we do want to go to an autonomous world. Now it's going to take time. It's going to take a lot of years, and it requires people to accept. But they've got the worst traffic problem, so it's a combination of autonomous and all a lot of new technology, routing models and so on, transportation models. So the things like, the questions like, what if we never build another road? You've got this huge city that says, okay, we don't want to build another road again, maybe in the future, or we don't want to, build another parking spot. We just stop building any more parking, because parking takes the most time. It causes the biggest congestion. Most of the time, people are searching for parking spots. So they found, I think it's like 50–60% of the time, the people who are driving in a city are searching for parking. So you can actually, if you can automate that whole parking operation, then you can actually reduce congestion significantly. So there's this whole organization called the National Association of City Transportation Officials. It's got all the different cities signed up, and they've got all these, they're putting out all these manifestos and blueprints on how the world is going to look like for an autonomous future. So on one side, you've got certainly all the technology companies like Waymo and everybody else building all these cars. On the other side, the cities are also looking at how are we going to change? What do we need to make happen? So one of the things is managing the curb. The curb is like sort of the it's not only for reducing congestion, making it very much more comfortable for people. It's also for reducing deaths, because a lot of pedestrians get killed. I mean, there are people who are trying to catch an Uber or something and they get hit. So bicyclists and so on. So and we look at some of the cases here. Plus, they want to make money, so it's pricing the curb. They have all these assets. They like to the cities are also like looking at ways by which they can, make money, through the curbs. So new models for curbs and managing curbs in real time. So some of the challenges are, how do you detect if you have an autonomous, vehicle? How does it detect pedestrians? The prediction, it's called a detection problem. And then how do you handle pedestrians right away? So it's got to figure out sometimes a human being can look at the person and know from their eye they're going to cross or not. A car cannot make the decision. It's much more difficult. So how do you maneuver on bicyclists and pedestrians and so on? So the various problems out there, and this is going to require a lot of edge computing and sensors on the curbs and on the streets. And so the design challenge, and that's what I'm sort of coming back to, it's really all about a local data cache. How do you have a local data cache that you can trust and sync between participating members? And how do you keep it in sync with a citywide cloud? So this is where the blockchain technology can prove extremely useful, because now you can have this local cache. You can synchronize among curbs, for example, and you can also synchronize with the cloud. And how do you ensure security of these sensors? So we are building, some new types of apps for this smart city. These are still under, working. So these are under evaluation, under development, and it's a slow process. So it's not like it's going to happen tomorrow, but the idea really is to get ready for that tomorrow. And that includes things like privacy. So we are working with new types of ways by which, images, for example, are not stored in the cloud. So if you are handling on the edge, you could take an image of a person, but you process it, but you don't store in the cloud. So the cloud need not be necessarily part of every problem. You can also do a lot of the computations, locally. And we come back to this picture here. So even with curb management, we see a huge role that in-memory computing is going to play here, and driving the data, synchronizing the data, using blockchain technology to drive trust, drive security, and reverse, the performance of both here and here. So that's where really this the role here is extremely important. And so I won't go into the use case in detail here, but it's what we have here is, you've got these curbs, and you want first you want to add the curb to the blockchain. Then you want to register the vehicle request to the blockchain. Then when the vehicle requests for a curb, it's like a get operation, and using an API, and it gets a request, or it tells it which curb it can go to. And if that curb is taken, as the car goes to that curb, if you have a delivery van come and take it up, it's immediately routed to a different curb. So you have to be able to work in real time. And it also includes abnormality. So it's looking for abnormal patterns. So if you have some sort of hacking going on, so there will be alerts to. So sort of looking at now a bigger picture, what are some typical blockchain apps? So you've got things like certainly cryptocurrency, provenance, which is ownership, managing supply chains, audit, for example, IoT applications, manufacturing, and micro. So let's look at the type of blockchain. So I sort of we'll step through the thing. So if you're using a cryptocurrency, you're going to be using a public one. You can also have private for cross-border, payments. Provenance, it's both public and private. So it's a combination of public and private. So you could have all the way down to like micro applications. You might be having an application which is looking at system reliability engineering, and you build a private blockchain and a public blockchain. So the members here, for example, if you have cryptocurrency, you've got traders, buyers, sellers, provenance, owners. So these are the different people. So in our IoT application, the curbs, for example, would be the members. The vehicles, the passengers, these are the members of the blockchain network. The major benefit, again, and the keyword is trust. The biggest benefit here is trust. And finally, in terms of in-memory computing, the benefits come a lot from boosting performance, from supporting a distributed model, and certainly in terms of supporting edge analytics and so on. And quickly, another area is manufacturing. So there's this platform called FarEdge, which has been adopted by all these companies up here, and they've actually adopted a they've adopted the edge computing, cloud and edge computing, and they support distributed ledgers. So this is another case of this whole area of factory automation, which is adopting the distributed ledger. So I'm just going to put this one back. So this is sort of the biggest benefit we see, and that's the that's what I had. So feel free to contact me, and I'll be glad to if you have any use cases, if you like, if you're looking at some projects in terms of blockchain, we are building some things with the city. We're also building a platform around which will package in-memory architecture to boost the performance of blockchain. So new ways of sharing the ledger. Thank you.